Okay, so today we're going to do a demonstration on a synthesis reaction. So I have my hair pulled back. I'm going to put on my goggles. So if you look at your synthesis reaction activity that I've posted for you, all right, the first one we're going to do is I have a strip of magnesium. So let me get this close so you can see the physical properties because there's a question about the physical properties. Okay. Now I'm going to burn this magnesium. Now magnesium burns very bright, so we are never going to look directly at the flame because it does burn so bright. Magnesium, burning of magnesium is also how we get like the white color for the fireworks. All right, and I'm going to burn my magnesium and I'm going to hold it over my dish so that we can catch the products. So within my not my petri dish, but within my dish here, you can see I do have some ash. Okay, so what did I make? Magnesium in the presence of oxygen. So this is a synthesis type A, according to our reference tables. We are creating a binary compound, magnesium oxide. Now, if you look, it asks us to mix the magnesium oxide with water. So before you watch the video of the second part, I would like for you to pause this. I would like you to fill out the information that is on your worksheet. I'd like for you to write that reaction, balance it, draw the particle diagram like it asks you to do. Go ahead and answer all of those questions. Okay, so next step, it asks us to add some water, a couple of drops of water to our magnesium oxide. So I'm adding some magnesium or some water to my magnesium oxide. Now, a metal oxide plus water produces what? This is what type of synthesis is going to produce a base. And in order for us to determine if it's a base, if it did in fact produce a base, we are going to use some phenolphthalein. All right, so I have some phenolphthalein here. Now, phenolphthalein turns bright pink in the presence of a base. Okay, so let me readjust my camera here, see if I can't. All right, and let me put in some phenolphthalein. What color do we notice? If it is in fact a base, this phenolphthalein, which is colorless to begin with, but it will turn pink. Okay, so it did turn pink, which is going to prove the presence of a base. So go ahead, pause this video, fill out your information sheet, and then come back and watch the third one. All right, so we've been asked to add water to a beaker, and I've got a little too much water. So I'll dump some out. And then we're going to add some bromothiamyl blue. All right, and it says what color is it? Okay. So we're going to look for the color here. And it's kind of hard to see. So I'll hold up a piece of white paper behind it. All right, and you can see here that that is a faint blue color. Now, bromothymol blue does turn yellow in the presence of an acid. So what I'm going to do is I'm going to exhale. All right, when we exhale, we produce carbon, or we release carbon dioxide. So carbon dioxide plus water should form what? An acid, carbonic acid. So if in fact I am forming an acid here, we're proving this type of synthesis that a nonmetal oxide and water does form an acid. All right, so let me get going on this. And check this out. The color has already changed. Let me do just a little bit more. The color is kind of hard to see on camera. But you can see it is a slight yellow. It's more yellow in person. I'm sorry y'all aren't here to do it in person. But it is definitely more yellow in person. But you can see, I can see that you can see it is a slight yellow. All right, so proving the three types of synthesis reactions that we have looked at.